to my channel, Java with Hawa. So today I'm going to be solving LeetCode question number 200, number of islands. So the question is, given an m by n 2D binary grid which represents a map of one's land and zeros which represent water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, so here is an example grid of an island. So here we have these connected ones. So this is connected horizontally, and then this is connected vertically here. This, and this, and then this is also connected vertically. So this whole grid over here. So the output here is 1. So because this all makes up one island, because they're connected horizontally and vertically. So in the second example, we have one island here in the top left. These are connected horizontally and vertically. We have another island here that's just by itself. So that's its own island. So that's the second island. And then there's another island here that has just connected horizontally. And our output here will be 3 islands. Alright, so if I go to my online whiteboard here, let's see, 1 1 1 1 0. So 1 1 1 1 0. I think it was 1 1 1 1 and then 0 and then 1 1. I don't know. Yeah, it's just 1 and then 0. Everything else is 0. Okay, so 0 0 0 0 0 0 0 0 0. I think that's too many zeros. Okay, no, that's good. So this is our island here, and basically the idea is we're gonna have to traverse through the entire grid or island because we have to look for all possible islands. So the idea is we traverse through, and anytime we see a 1, what we have to do is check, okay, how many horizontal or vertical neighbors does it have? Well, not necessarily how many, but we'll explore all of its neighbors and then we'll count that as one island. So the idea is we need to do a depth first search. And if you don't know what depth first search is, it's basically like an algorithm for trees and graphs where basically you start at the root node, or in case of a graph, you can start at any arbitrary node and call it the root, and then explore all possible branches or paths or neighbors, whatever, until you've exhausted your possible routes, and then it will backtrack and basically give you your answer. So that was kind of a confusing way, but so it basically explores as far as it can. So let's say this was the root. It explores as far as it can along each branch or each path before backtracking and giving us the answer that we want. So the idea is we do a depth first search, and when we see 1s, we're gonna change them into zeros. So here, this will become a 0, this will become a 0, this will become a 0, just to show that these are all part of the same island, so we don't count them twice. So the idea is that each time that you turn a 1 into a 0, you're basically saying, okay, your island is comprised of these stones. These are all stones. All the 1s are stones. Each time you see a 1, each time you see a stone of the island, push that stone underwater, and then as a result, at the end, you basically get your island back, but technically your whole island is underwater. If they wanted us to maintain this island and keep it intact, I haven't tried this approach, but I think what we could do is first traverse through this and increment everything by 1. So we'd have something like 2 2 2 2 1 2 2 1 2 1 2 2 1 1 1 1 1 1 1, and then do the exact approach, depth first search approach, but instead look for 2s and then change those. Look for 2s and then change their corresponding values. Oh my god, that won't work. Just forget I even mentioned that. I need to think about that further. Forget this whole thing. Anyway, so this is the approach. So we're just gonna start. And yeah, so the idea is here, like I said, we're just syncing the island together. That that make up one island. So we don't want to count this as one island. This is another island. This is another island, because it's not separate islands. These are in total one island. So the reason we switch these to zeros is to make sure that we're returning these as one component and syncing them together. So we're making sure to not double count any island. And yeah, anyways, let's just get started. We're gonna do a depth first search, like I mentioned. So here we go. The first thing I'm gonna check is if grid.length equals 0. Actually, first we'll check the more like robust case. So if grid equals null, or grid.length equals 0, then we'll just return 0, because there's obviously 0 islands, so return 0. And then else, this is when we get started. So we'll say, okay, what are we gonna say? So we're gonna have to traverse through our entire island. So we'll say, we'll need a nested for loop for that. So for int I equals 0, I is less than grid.length, I plus, and then, so this is the kind of the height of the island, and then j will be like the rows of the island. So for int j equals 0, j is less than grid at I dot length, j plus, and then this is when we can get started with our code. So we'll say if we come upon a 1, in our grid, then that's when we need to start doing our depth first search to explore all other possible neighboring ones that will make up one island. So we'll say if our grid at ij equals equals 1, then okay, so if grid at ij equals 1, then this is when we'll call our helper method. So I'll say call helper method to perform a depth first search. And actually, I forgot one important key. I need something like a counter to keep track of the number of islands, or else what am I going to return in the end? So int number of islands, we're going to initially set it equal to 0, and then we're going to return that at the end of our method. So return a num of islands. Alright, and then here, so like I said, if grid.ij equals 1, then we're gonna have to increment the value of num of islands by some number, and that number will be determined by the number of islands, by the islands that we find in our depth first search. So num of islands plus equals some helper method here. So now I'm going to write that helper method. So over here we'll say public int, I'll just make it private honestly since it's a helper method. So private int, and we'll call it perform DFS, and we're gonna perform a depth first search, and we're gonna pass in our char array or island. I should call it island or grid, I don't know. And then we're gonna have to pass in the indices where we found the one, so that we can start exploring all possible like neighboring ones to get our island. So I repeated that like 10 times, so sorry if it's repetitive. But anyway, so we have this, and in here we're gonna say, first we're gonna check to make sure we have passed in right bounds just for security. So we're gonna say, okay, if we are above the island, if we're below the island, if we're too much to the left of the island or too much to the right of the island, or if the indices somehow, maybe something got messed up here, we're gonna double check. If the grid at ij equals 0, then that's when we need to just return 0. So I'll say if I is let's see, if I is less than 0, or I is greater than or equal to our grid.length, or j is less than 0, or j is greater than or equal to our grid at I.length. What time is it? Okay. Our grid at I.length, or grid at I. Okay, this check that I just mentioned here, grid at ij equals 0, it doesn't necessarily mean, oh, something went wrong here. When we see a 0, when we've exhausted the path, then we need to just return 0, you know, because there's no more ones in the path. So if grid at ij equals 0, then just return 0, and this is where our recursive like backtracking stops because it's basically exhausted the possible routes. So else, I'll just put an else here. I wasn't gonna write s. I mean, we don't need it. We're returning. So now we'll say, okay, now perform DFS or depth first search. Perform it on the top neighbor, check if it's a 1. Perform it on the bottom neighbor, perform it on the left, and perform it on the right because our instructions said that an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. Oh my god, why do I keep saying horizontally? Okay, horizontally or vertically. So basically, a string of 1s up, down, left, or right. So I'll say, okay, perform a DFS, pass in your grid, take your I plus 1, right? Check the top. So this is the top. Check the top, keep your J the same. So check the top. Then perform. So this is not even the right method. Perform DFS. And then I can say perform DFS. Let's check the bottom now. Let's check if the bottom neighbor is a 1. So perform DFS grid I minus 1 and J. So this will say check the bottom neighbor. And then we'll perform a DFS of grid I. Now we're going to check the left neighbor. So J minus 1. Check the left neighbor. And then we perform a DFS grid I and J plus 1. So check the right neighbor. And once it's exhausted these possible paths, we're gonna return 1 because these all make up one island. So return 1. And this should be it for our depth first search method. So in here, when we said num of islands plus equals, so we'll say num of islands plus equals perform our depth first search grid. We're gonna pass in the indice we're at and the J indice we're at. And that's about it. We return num of islands, and this should give us our solution. And like I said, the time complexity will be O of m times n, where m is the length of the grid, like the number of, is it columns or rows? Number of columns. No. Number of rows. No. 0, 1. Okay, I don't know. I think I said it. Wait. I is this way, right? Rows, and J is columns. Or I is columns and J is rows. Anyways, you know what I mean. I have to go look at that again. But yeah, this should work, so I'm going to just test it out. First, I'm going to make sure I don't have any syntax errors in here. Okay, looks good. Let's run that and see what we get. Oh my gosh, does not look good. Grid. Grid. Okay, hopefully this time it works. We have to, like I said here, we need to set these to 0, and I didn't do that anywhere. Therefore, we got a Stack Overflow error. So we'll have to say grid at I, J equals 0, and then that should solve it. So yeah, with recursion, I guess you have to be super careful, or else everything goes to hell. Okay, so we're just gonna submit this and see if that works. And yeah, that works. So hopefully this video was helpful. Yeah, thanks for watching.